So good afternoon, everybody. Can you hear me? You cannot hear me? Then you have to take a headset. Without headset, you cannot hear me. I'm not shouting so loud, so please give them a headset so they can listen to it. So yeah, it's a pleasure to be here again and talk a little bit about my experience with Hanita lenses. This time we're talking about the Hanita Extend. It's the new monofocal plus lens from Hanita, and we were comparing it with the Eyehance lens, which more or less is the lens that gave the term of monofocal plus its first expression. And we're talking here about the so-called Axicon principle versus the central elevation high asphere version that we see with the Eyehance. And if we look at it, in former times we have a lot of normal monofocal lenses. Now we have, from almost every company, monofocal plus lenses, and that's not even all of them, quite a bit. And the same way we have a lot of EDOF lenses and trifocal IOL, so the monofocal plus lenses now become a very big category, and also a category where a lot of people don't know which one they should choose. Let's look into the monofocal plus. Interestingly, most of the monofocal plus are kind of clones from the very first one, the Eyehance, using high aspherical components of the IOL optic. Either you do it on one side or on both sides, or with slightly different ways. All of these lenses are more or less the same if you look at it from an optical standpoint. And this actually is the first thing where it started with the so-called high-order aspheric components. When we looked at this in the lab and we compared all these lenses, we could see a lot of differences also among them, but also a lot of things that they have in common, especially in a normal pupil of like 3 millimeters, as you can see here. Most of them are pretty close together. They are not as good in the MTF function as a standard monofocal lens, but they are pretty close. When the pupil gets wider, you see some differences, as you see here. And here you also see that the Eyehance is pretty good and pretty close to the ICB, the normal monofocal Technis lens, compared to some of the other monofocal plus lenses. And from the first study that we did at that time, the clinical multi-center trial in Europe, what we found out is, what we saw was that the Eyehance had like one line better intermediate visual acuity in the study, which was significant. And a lot of other studies shown similar outcomes, and also a slight increase in defocus, as you can see here, in this also multi-center trial. Well, if we look now at the Extend, they use a so-called Bessel beam generation function to get an elongated depth of focus with additional optimization for intermediate vision, and a conical, you see the illustration, a conical Axicon surface to provide an elongated depth of focus. And for pupil diameters over 3.5 millimeters, the surface is optimized to maximize the energy for far vision under mesopic and scotopic condition. This technology is actually a way a lot of lasers are working. Bessel beam technology is used in laser application to more focus and get a better depth of focus of the applied laser energy. If you want to cut material, if you want to penetrate a tissue and you want to do some diagnostic, you can use this technology in order to manipulate the beam of light, because laser is light. Yeah? In the same way, this technology is used for an intraocular lens where you look through something. We actually put the lens on the optical bench with the trioptics machine here, as you can see, measured under different conditions using polychromatic light. We took 20 diopters as a standard sample, and then we compared it also on the optical bench with the Eyehance lens. And what we can actually also do with lenses that we see from the modulation transfer function, and especially from the area under the curve, so it's called the MTFA, we can very closely simulate visual acuity, and we can simulate that in relation to several things, to depth of focus, to dioptric power, to MTF values, and this way we get a very close idea how a lens can perform in clinical situation. If we look at the Extend and the ICB with the far MTF, as you can see here, you see it's completely identical, so there's almost no difference. You get the same MTF curve for both lenses, so it's more or less identical. At the larger pupil, you can see a little bit more optimized design for the Extend with a little bit better MTF at certain spatial frequencies. If we look at the defocus curve, and this is a simulated defocus curve, you see also that you get the same amount of depth of focus from the Extend lens compared to the Eyhance lens. So virtually they are the same when we look at these key features that define a monofocal plus lens. So we have here another thing is the defocus curve in relation to visual acuity, as you can see, and here also you see the very broad line of the defocus curve, and we look usually at 0.2 or 0.1 logma, and if you go there you see that you have 1.25 or 1.5 diopters of depth of focus. For monofocal plus, that's very good. You see here the United States Air Force target, something we also look at, and you also see that we got good to -1, and even see some details of -1.5 diopters. So this is the depth of focus you get with this monofocal plus Extend lens. There is not much difference between the point spread function between the two lenses, fairly similar as you can see here. These are defining how much side effects or dysphotopsia you have, but this is a typical monofocal profile. We put the lens in the last couple of weeks, last 4 or 5 weeks, I had the opportunity to start with the Extend and implanted a couple of those, so I can show you some clinical data actually. Here you see the implantation. First we do the capsulotomy. I like to use here the superimposed image with the 5.5 millimeter capsulotomy. Then we do a normal phaco here in this case. And then we will see the implantation. It's a normal cataract with a little bit of, let's say, grade 3 or something like this. Maybe I can forward, oh no. Now we're cleaning up the posterior capsule. And then we will see how we prepare the lens. Comes out, goes slowly in. You guide the first haptic under the capsulotomy rim. And then the second haptic comes out, being on the optic. And then we put it inside the capsular bag. So I tried to make it fairly slowly so you can see it better, because I knew I would use this recording for the presentation. And now the lens looks in. So we had like 19 patients I put in the last 3 weeks, 4 weeks. Some were binocular, some monocular. You see here the range that we did. The outcome was quite nice actually. Here uncorrected distance visual acuity was 0 logma, so to say, corrected even -0 logma. Intermediate 0.15 distance corrected. Uncorrected near visual acuity was 0.3. Uncorrected near visual acuity for an average monofocal plus is pretty good. It translates in 20/40 or 0.5, and this is enough to read newspaper actually. So if we have that on both eyes, it's fairly decent even for a normal patient to get a glimpse of what he's reading in a newspaper. But you easily can look at the mobile phone or the desktop computer. So that was quite surprising, because I didn't really expect in near acuity better than 0.3. You see here the 1 month defocus curve from a few patients. You see a visual acuity of 0.2 logma or better. So this is 0.63 from plus 0.75 to -1. So we have a certain refractive tolerance here. If we would actually target -0.5 as you see here on this curve. So if we would go, no, this is not going. No. If we would do that, moving this to here, then we would actually extend even further. So we can actually target slightly minus, still get full distance acuity of 0 logma, and enhance actually the depth of focus. And if you combine that with monovision, you can get pretty far actually with that. You see here another binocular curve, and binocular, usually the patients gain almost 1 line, and this also translates usually into like half a diopter more depth of focus, which we can see here also. So again, here you can also play with some mini monovision if you want to achieve good near acuity, but just for a monofocal intraocular lens, it gives you a broad landing zone. For example, also if you talk about post-LASIK patients, where you can be sure that you get up to 0.8 to 1.0 within plus minus 1 diopter of refractive outcome. So this refractive tolerance is one of the things we like about the monofocal plus lenses, and the Hanita Extend is actually doing the same. So to conclude, and I think we will listen to some more experience now with the Hanita Extend. For me, in a short time, I use the lens. It's a very nice new monofocal plus lens with the extended depth of focus, which can be extended quite a bit. It's a different design than the Eyehance lens with a Bessel beam generation function and the conical Axicon surface, as you can see here. And we had excellent refractive accuracy in the first implantation. I usually am worried when I put a lens in for the first time that A constant is right, but it was no issue at all. And then, as you can see, we had a visual acuity of 0.1 or 0.2 logma over a broad range of dioptric power. So I think it's a very competitive lens to the previous monofocal plus technology such as Eyehance, and I'm really looking forward to get longer outcome and more patients data here on this. So thank you very much. Comments, questions, yeah?
Thank you for nice presentations. Yeah, do you have any the optical bench test in case of the decenter?
Yeah, he was asking about the decentration of the lens. We are just working on it. We have a setup for this to look at decentration. I don't really expect much problems here in the, let's say, normal decentration range of between like 0.5 millimeter to 0.75 millimeter, but we will see that. I would have presented it if I have it, because this is also a strong argument for a good lens if you have this data. But in the short time, were not able to put that together.